Hi students, welcome to the next video, problem number 6 on design of multi-plate hatches. So let's look into the problem statement in the next slide. Alright, so problem number 6 is as follows. An oil immersed multi-disc clutch with molded asbestos on one side and steel disc on the other is used in an application. The torque transmitted by the clutch is 75 Newton meter. The coefficient of friction between the asbestos lining and the steel plate in the wet condition is 0.1. The permissible intensity of pressure on the asbestos lining is 500 kilopascal. The outer diameter of the friction lining is kept as 100 mm due to space limitation. Assuming uniform wear theory, calculate the inside diameter of the disc, the required number of discs, and the clamping force. Okay, so this problem states that uh, the multi-disc clutch is made up of asbestos and steel. Okay, so the steel disc will usually be mounted on the driving shaft, and the weaker asbestos sheets will be on the driven shaft. And the torque that is transmitted in this application is 75 Newton meter or 75,000 Newton mm. Okay, and it is oil immersed. Okay, coolant is provided, so you have a, a wet condition here, and we know from theory that multi-disc clutches are usually wet because of the higher friction there, right? Therefore, the coefficient of friction is 0.1. Intensity of pressure is mentioned to be 500 kilopascal, or 500 into 10 to the power of minus 3 uh, Newton mm, right, or zero point 0.5 Newton per millimeter square. Okay, 0.5 Newton per millimeter square the pressure, and the outer diameter is 100 mm. They have asked us to find out three factors. Number one, inside diameter of the disc. Number two, required number of disc, number of plates, and the third one is the clamping force, the axial force. Right. So let's look into the solution in the next slide. Okay, the data is given here. Torque is 75 Newton meter or 75,000 Newton mm. Intensity of pressure is 500 kPa or zero point 0.5 Newton per millimeter square. Coefficient of friction in wet condition is 0.1, and outer diameter is 100 mm. Therefore, they have asked us to calculate inside diameter di, number of plates n, and the clamping force. Right. So let's look into the solution in the next slide. All right, so let's look into the solution now. The first thing that they have asked us to calculate is the inside diameter di. They have asked us to assume uniform wear theory to solve the problem, to design the clutch. Okay, now to decide to calculate the inside diameter, we can make use of the torque equation, right? And they have specified that the torque needed in this application is 75,000 Newton mm. Therefore, the torque is known to us. Therefore, for uniform wear theory, we can make use of equation 13.9 F for the torque, right? And using, since we know the value of torque, you can try and calculate for di. But then there is a problem here. In this equation, we do not know n dash also. The number of contact surfaces is also unknown. Therefore, there are two like unknowns here. Therefore, we will not be able to use this equation as it is, right? Therefore, how do we proceed further? Now, in this case, you will have to make an like assumption here. Okay, uh, since we have two unknown di and n dash, we cannot use this equation as it is. We will assume that the clutch is transmitting maximum torque. That is, the torque of 75,000 is the maximum torque. Okay, now uh, it can be shown from theory that for uniform wear theory, the ratio of inside to outside diameter of the clutch disc is equal to 0.577. It can be proved. It can be shown that di by do is equal to 0.577. Okay, and this proof or this derivation is provided at the end of this video. We will see that at the end of this video. As of now, assume that di by do is equal to 0.577. Now this is available in some of the handbooks, but unfortunately for our handbook, it's not specified, right? Therefore, you will have to remember this. Okay, for maximum torque condition, the ratio of inside to outside diameter of the clutch plate is equal to 0.577. Right now, 0.577 is actually root of 1 by 3. Okay, so either way you can remember it. Right now, if you make this like assumption, then we can directly calculate the inside diameter di using this relation itself. Okay, therefore, di will be actually do into 0.577. That turns out to be 58 mm. Right, therefore, you have directly obtained the inside diameter di as 15 mm by assuming that the torque is maximum. The specified torque is maximum torque, or the clutch plate is operating at maximum torque. All right, okay. Now, the second factor which they have asked us to calculate is the clamping force or the axial force, the spring force. Okay, and for this we know, for uniform wear theory, you have the standard equation for axial force, FAW, equation 13.9D. Substitute the factors and you will get it as 1913.23 Newton. Right, therefore you can directly calculate the axial force. The third factor that they have asked us to calculate is what is the number of discs. Okay, now to find out the number of discs, we will first calculate the number of contacting surfaces n dash, and based on n dash we can decide the number of plates n. Now the torque we know, therefore from equation 13.9f we have the torque equation, right? And the torque value we know. And for uniform wear theory, the mean diameter we know is the average of inside and outside diameter, and that turns out to be 79 mm. The average diameter is 79 like mm. Okay. Now substitute in the torque equation. The torque we know is 75,000, and you know all other factors but n dash. Solve for like n dash. Therefore, the total number of friction surfaces or the contact surfaces n dash turns out to be 9.92 or approximately 10. Right now, we know that the total number of plates is equal to number of friction surfaces plus 1. We have seen this in that figure in video number 4. All right. Therefore, n is equal to n dash plus 1 is equal to 11. Therefore, the total number of plates is 11. Right. Therefore, out of that 11, we know that we usually take the higher number of plate in the driving shaft and lower number of plates in the driven shaft. Therefore, we will assume 6 plates, 6 steel discs for the driving shaft Z1 and 5 steel discs with asbestos lining for the driven shaft. Right. Therefore, the total number of plates is 11, and we will split it up into 6 and 5. All right. So that solves this problem. Okay. All the the 3 factors are known. Now, in the next slide, we will look into this derivation of di by do equal to 0.577. The proof for that, I've taken it from Bandari book and I've represented it here. Let's go through it. All right, so let's try to prove that the ratio of inner to outer diameter is equal to 0.577. All right, now to actually prove this, we will say begin by assuming the ratio d by d. In this, small letter d is actually inside diameter, capital letter D is outer diameter. We will assume d by d as equal to x. Okay, and for uniform wear theory, you have equation for torque as equation B here. Now this is the same equation you have in your handbook. Now in your handbook, this equation is given in 13.9F. 13.9F is this equation here, right? Now, if I substitute d by d as x here, that is, if I take capital letter D like outside this bracket, then you will have the ratio d by d here. Okay, and this equation will now turn to x into 1 minus x square. That is, if you will substitute d by d as x. All right. Therefore, this is the way the equation will change. Right now, this formula, you will see that PA and D mu are all fixed values, right? Therefore, this is a constant value here, and what varies here is the ratio d by d, right? Okay. Now, uh, for maximum torque, that is for torque to be max, for MT to be maximum, for the like, torque to be maximum, we like know that slope of this equation should be equal to 0, or the derivative of this equation should be equal to 0, right? Therefore, derivative of mt should be equal to 0, or the derivative of this varying factor x into 1 minus x square is equal to 0. If you derive this, you get it as 1 minus 3x square equal to 0, or x is equal to root of 1 by 3, which is equal to 0.577, right? So that is how we get the equation d by d, ratio of inside to outside diameter for transmitting maximum torque, is equal to 0.577. Now, if I will express it in a graph, that is, if I will rearrange this equation C, that the fixed values I will take it to the left, and the varying factor I will keep it to the right, then this factor here can be called as the torque characteristic. And x we know is the ratio of inside to outside diameter. If you will draw a graph here, you will see that for a value of d by d equal to 0.577, the torque characteristic graph becomes maximum. It will reach its peak, right? Therefore, 0.577 is the ratio of d by d at which the torque is maximum. All right. So, if you will look at the next slide, for optimum ratio, therefore, d by d, the ratio of inner to outer diameter should be equal to 0.577, right? Or if you will inverse this, it becomes 1.732. Okay. Therefore, while designing a clutch plate, it is always a good practice to keep the ratio of outer to inner diameter between 1.5 and 2. All right. Okay. So with this, we end with uh, problems on design of clutches. This will be followed by assignment and quiz. Thank you.